If we break apart the word polynomial, it really tells you exactly what a polynomial is. So the prefix poly, P-O-L-Y, there really means many, and then when we think about gnome, it's kind of referring to different sorts of terms. And so really ultimately what a polynomial is it's some sort of an expression where you're adding together a bunch of terms. So I'm going to jump right to what standard form of a polynomial is, and that gives you a good flavor of what polynomials will look like. So a polynomial will involve some variable, or it could even involve variables, but I'll just use one variable that is raised to some sort of an exponent. Now it's got to be like a whole number exponent. So that n that I put there might be like a 43 or something like that. Now it is allowed to be multiplied by some coefficient, some number there. And then we can keep adding terms, but we want these exponents here to be in decreasing order. So like if that was a 43 right there, then this would be 43 minus 1, so it's 42, right? And so then we would just kind of keep going, plus then another coefficient times x to the next lowest power, plus keep going all the way down until we get to another coefficient times, like just, x. And then finally, we're allowed to have then just some number that we add at the very end. Now, those a's don't all need to be the same numbers as one another. So if I call this like a sub n, so there's that little subscript n, it just labels that coefficient differently than if I call this a sub n minus 1 and a sub n minus 2, and then if I just call that a sub 1 and then a sub 0, then actually all those a sub whatevers then can be allowed to be different numbers. So that's exactly what a standard form of a polynomial is that you need to make sure that you have the highest exponents at the beginning, and then it goes in decreasing order from there. So like by example, if you had negative 1/8 x to and the exponents have to be whole numbers, so like to the 17th plus the square root of 3 times x to the 14th minus 0.1 x to the 10th plus 121 x to the third minus 1x plus pi, like that would be an example of a polynomial, and it's also in standard form since the exponents go in decreasing order. So whenever we're dealing with polynomials, we'll get more into classifying them in depth later on, but at least at this point, we want to be able to understand how we can classify a polynomial by how many terms it has in particular. So, for example, you might have a polynomial where you have like this, just like a 4, or maybe you have just like a x, y, z to the second sort of polynomial, or you have like 3 v to the third. All of those are examples where there's just one single term involved, and so what we call those is we call those monomials, where there's just a single term in the polynomial. So just one. When there's two terms, so like if you had 3x minus 8, or if you had 1/3 z to the second y plus x. Those are a couple examples where there's two terms in the polynomials, and we call those binomials, since bi refers to the number 2, of course. Whenever you have a 3-term polynomial, so you might have like, say, x to the 4th minus 5/4 x to the 3rd plus 1/7 x, like that would be an example of a trinomial, where you've got 3 terms. And then anytime your polynomial has 4 or more terms, we usually don't give it any more of a specific name, so then you'll just revert to calling it just a 4-term polynomial if it's got 4 terms or whatever it might be, right? So if you had like x plus y plus z plus a plus 3, like that would be a 5-term polynomial that you could call that. Now just note that these here, right, they're still polynomials, so like if you want to call a monomial a polynomial, you still can. It's just nice, like if it is a binomial, you can call it a monomial because that's most specific, and by calling a monomial, that of course implies that it's a polynomial. So when you take a look at these examples right here, when you classify the polynomials by the number of terms, it turns out that that's a binomial. This is a trinomial. This right here, you would classify it as a monomial. The last one has 4 terms, so you would just call it really like a 4-term polynomial there. And then not all of these polynomials are in standard form. I did say here that you should rewrite each of these in standard form if applicable. So like here, the constant's at the beginning, you don't want that, so you actually need to rewrite it as the negative 2x first and then plus 8, and that would write that in standard form. It turns out that that right there actually is in standard form because the exponents do go in decreasing order. Obviously, there's no way to rearrange that. And then the last expression right there, that's good because 4 is the highest exponent, but then you have the negative x to the third, which would come next, and then your x squared term, and then finally the degree 1 term would come at the end there, so that would rewrite that into proper standard form order there.